This is going to be a critical examination of Einstein's theory of the relativity of simultaneity. Sounds complicated. All it means is that two events that occur at the same time, that is, simultaneously for one observer, supposedly those same two events will occur at two different times for another observer. No background in physics or mathematics is needed. I'll be speaking in plain and hopefully simple English. In order to establish his theory, Einstein uses the illustration of a moving train. Now, in the center of the train, that is equidistant from the back wall and the front wall of the train, there's a light source emitting beams of light. Now, according to Einstein, the light beams will strike the back and the front wall at the same time for the inside observer. The reason for this is that for him, the train is not moving because he's moving along with the train, so it's not moving relative to him. For the outside observer, however, someone who's situated on the embankment, the train is moving relative to him. So, according to the theory, the light beam will strike the back wall of the train first because it's moving towards the light beam, and at a later time will strike the front wall of the train because the front wall of the train is receding away from the light beam. I call this the ostrich theory of physics. The reason for this is that Einstein and the relativists believe that there's no such thing as an independent trajectory of the train. In other words, because the train is not moving relative to the inside observer, the laws of physics applies to him as though the train were not moving. And yet, because it is moving relative to the outside observer, uh, uh, the laws of physics applies to him as though the train is moving. A good friend of mine, Bob, said, "Well, why doesn't the inside observer just look out the window and see that the train is moving?" And well, you see why I call this the ostrich theory of physics. Anyway, let's proceed with Einstein's assumptions. Now, during the period of time that the light beam struck the back wall of the train, and then at a later time the front wall of the train for the outside observer, a poor fellow on the train had a heart attack and dropped dead. Shortly thereafter, the train comes to a stop. The outside observer, who also happens to be the town coroner, approaches the train and says to the inside observer, gee, where's the body of the fellow who had a heart attack and died? The inside observer, in astonishment, says, a fellow died? When did that happen? The outside observer says, well, in that period of time when the light beam struck the back wall of the train and then at a later time struck the front wall of the train. The inside observer says, well, there was no such period of time because both light beams struck the walls at the same time. Well, the question now is, do we have a dead body or don't we? I like to call this dead man walking. We should note at this point that the event could have been any event. Uh, in any period of time in the universe, there are a countless number of events. And if there were a time that they have occurred in one person's world, but not in another person's world, we see that this would separate their universes, separate their worlds. We can extend this time difference to the theory of relativity of time in general. Most of us have heard of the tale of a rocket ship taking off from the Earth and traveling at tremendous speeds approaching the speed of light. And according to the theory of relativity, the time on the rocket ship will slow down compared to that on the Earth. Let's assume that this time difference is 40 times. So for every 40 hours that pass on the Earth, only 1 hour passes on the rocket ship. And thus, for every 40 years that pass on the Earth, only 1 year passes on the rocket ship. But this time that passes on the Earth, the 40 years, as any 40-year period that passes on the Earth, is not physically restricted to the Earth. It's not dependent on the physical location. In other words, it extends out to the entire universe. So for the people on Earth, 40 years have passed in the entire universe. Indeed, it's 40 years have passed even on the rocket ship. The Earth has gone around the sun 40 times. Meanwhile, we're supposed to believe that the people on the rocket ship have only experienced 1 year But again, their time is not limited to their physical location, but also extends out to the entire universe. So it's difficult to reconcile the Earth, the universe having aged 1 year for one group and 40 years for another group. To the people on the rocket ship, the Earth has only traveled around the sun one time, the same Earth and the same sun. So we see how extending different rates of time to different people really ends up putting them in very different and incompatible universes. Well, please look for my previous video, which goes a little bit more into detail about the rocket ship tail. But also, please look forward to my next video, which will demonstrate that positing different rates of time can only occur if we're assuming a common universal time. And of course, once we assume a common universal time, we negate the existence of different rates of time. Well, listen, I thank you very much for your attention. I hope this gives you something to think about. And in the meantime, as the cowboy says, or used to say, happy days to you until we meet again.